Hi students, this is a follow-up on our lesson today on measures of central tendency. We're going to talk about the two last things that we didn't get to in our lesson today. First of all, measures of variation. We really talked about measures of central tendency in the first part of the lesson, which is the finding the value that best describes the data. Okay, we think about the middle, like the median or the average or the mode. It's the most representative of the data. So this is a little different. This is measures of variation. What is the spread of the data set like? What is the range? Range is one way to describe. Okay, so let's talk about, that means how much does the data, how much does it vary from the mean of the data? Okay, that's really what we're looking at. How much does it vary from that mean, from that central number? Okay, so just looking at this chart here, this is in your book. This tells you how to find variance and standard deviation. We're going to go through it, but you can always come back to this, so I'm not going to go over it just now, but we're going to go through it when we do a couple problems. I want to show you an example problem. All right, we're just going to look at this problem for a minute. Going to highlight some things on it. Okay, so the first thing that we do is we find the mean. You can see here that the mean is, oops, didn't mean to do that. You have to be on the highlighter. The mean here is, it's denoted by this X with a line over it. Okay, so that's what we're going to use for mean. That is the mathematical symbol for mean. We find it by adding all the data together, dividing by the number of data, and for this data set we find 10. Then we are going to find the difference between the mean and each individual data value. Okay, so, and we're going to square it. Okay, so we find the difference, which is X minus the mean, right? Each X value minus the mean. And these are all our differences here. 6, 9, 36, 1, 49, 9, 1, 4, 1, 36. We add those together and we divide by 10. And that is the variance. Okay, so adding all those together and dividing by 10, oops, didn't mean to cross out the answer there, gives us this 16.2, which is the variance. Last thing, we find the standard deviation, which is the square root of the variance. And you're going to see in an example coming up of how we can use the standard deviation, how it's kind of helpful for us. Okay, so the mean is 10 milligrams. The standard deviation is 4.02 milligrams. Okay, this was a amount of a substance found in a patient's blood. Standard deviations has to do with how much it varies. If your standard deviation is much larger, there's a lot of variance, right? If it's smaller, then there's not so much spread for your data. Okay, so you're going to see how we're going to use standard deviation in a problem coming up here. Okay, the problem is we have a data set that gives the calories in a 1-ounce serving of breakfast cereal. Find the variance and standard deviation. Okay, did the math with my calculator, added all the data together, divided by 9, and I get a mean of 114.4. Next thing I'm going to do is find the difference between each value and the mean and square it. Okay, so I've listed out my the values of my data set first. Then I just wrote my average across, and then I found the difference between each value and the mean, and then I squared that. These are my values where I'm going to add them together and divide by, I think there's 9 values. Okay, and what I get here is 122 point, let's say 0.7, we'll round. That is my variance. And my standard deviation, oops, this was squared, right? Because that's my standard deviation. So variance is standard deviation squared. And then when I take the square root of that to find my standard deviation, the square root of that's going to be around close to 11, 122.7, and I take the square root, and it's 11.1. Okay, so let's go back and look at this problem again. This problem was talking about calories in a 1-ounce serving of breakfast cereal. The standard deviation is 11.1 calories. Okay, so let's see how that's useful. It's useful in our next problem in finding outliers. Okay, so what is an outlier? It's an extreme value that's much less than or much greater than the other data values. So you have a bunch of data, and then you have this number that's just way off, much bigger or much smaller. Alrighty, it throws off your average a lot. Okay, so we want to identify outliers. If an outlier, we'll look at this in the next section, but sometimes if we're looking at trying to find the measures of central tendency, we might want to throw out the outlier or use a different measure because that can throw off, particularly throw off our mean. So do you think outliers have a stronger effect on the mean or median of the data set? It's an important thing to think about. If I have an outlier, say this is a data set, right? I have an outlier. This looks like an outlier, okay? If we look at what is our mean with the outlier and what is our mean without the outlier, we get with our outlier, including our outlier, we get 10.6, and without the outlier, it's 11.7. So you can see it does throw off the mean. Ooh, let's see what it's going to do to the median. Okay, so the median is the middle number, right? In this case, it is, I've got 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Yeah, and our median is 11, so it doesn't even change the median. So typically outliers really have a strong effect on the mean, and we need to be careful. And one place that you'll see this is home prices in Marin County. If you read the IJ, the front page of the IJ every 3 months, quarterly, is an article about the median home prices in Marin. And the reason they don't say the average home price in Marin is because there are some outliers in Marin. When you have a $5 million house where most of your houses being sold are around $1 million, or you have maybe even a $10 million house or something, it makes a huge, huge effect on the average. So in Marin County, it makes more sense, and in most housing is just reflected this way. We talk about the median house price, okay, and that's because we want to make sure that we're not getting affected too strongly by any outliers. Okay, so one way, let's look at this problem, and one way to find an outlier is it's more than 3 standard deviations from the mean. Okay, either direction, greater than or less than the mean. If we have a number that's more than 3 standard deviations from the mean, we consider it an outlier. So now we're going to use the standard deviations to look at a data set and see if there's any outliers here. So in 2003 and 4, the American League Championship Series, the New York Yankees scored the following number of runs against the Boston Red Sox. Okay, a lot of sports statistics out there. Identify the outlier and describe how it affects the mean and standard deviation. So let's do this problem. I'm going to kind of run through it rather quickly here so I don't rack up the time. We need to first find the standard deviation. Okay, so let's go through that process. Okay, we're going to do this one on our calculator. You're going to put all your numbers into the stat, let me go back, the stat function, and you're going to put them into L1. You need to delete anything else out of L2. You've just got one list, L1, and you're going to put these numbers in, okay? Then you're going to go ahead and do stat, this is stat edit, and then you're going to do stat calc, and you're going to do 1, 1, which is variance statistics, okay? And what you're going to see is that the mean is about approximately 5.4. You're going to see a bunch of different things here, but if you get down to the standard deviation squared, that is standard deviation squared is, okay, I misspoke. You're not going to find the standard deviation squared of the variance. What you're going to find here is just the standard deviation, and that is 4.3. Okay? So then what we're going to do is we're going to actually look at what our average, right, is 5.4. 5.4. 3 standard deviations is 4.3 times 3, which is 12.9. So 3 times the standard deviation equals 12.9. So we're looking to go 12.9, right, minus 12.9 to either side greater than or less than the mean of this data, plus 12.9. So what we would get there then for that number when we add the 3 standard deviations or subtract it. So when we subtract 12.9 from 5.4, we get a negative. And obviously we're not going to have a negative number of runs. So really we're just going down to 0 here because we're going to run past 0. It doesn't have any meaning. So anything, there really aren't going to be any outliers that are, there really aren't going to be outliers that are less than the average. But looking at greater than the average, anything that is larger than, any value that's larger than 18.3 is going to be an outlier. And looking up at my data set, that would make 19 an outlier. Okay, how does that affect the mean and standard deviation? With the outlier, we already calculated it. We get a mean of 5.4 and a standard deviation of 4.3. Without the outlier, my mean changes from 5.4 to 4.2. Makes sense that it would be lower. And then my standard deviation, which shows how much the variance in the data is 2.1, significantly less. So if we're comparing them, we don't want to just say one is bigger than the other one. We want to actually show the values. So I want you to both be able to calculate standard deviation without a calculator and with a calculator. You definitely need to be able to show on a test that you know what standard deviation is and how you get it. So you need to be prepared to do it without a calculator. However, on some of your homework problems, it might make sense to do it with a calculator. So just know both ways. And that's it on the lesson. Let me know, please, if you get really stuck in some problems, give me a heads up. Let me know so that we can keep moving forward and not use too much class time to go over homework. All right, have a great weekend, and I'll see you next week.